Hey guys, today we're going to be covering solving quadratic equations and systems of quadratic equations algebraically. Now, there's a lot to this particular lesson, partly because there's some assumption on my part that many of you are not super comfortable with quadratic equations themselves. So today's main focus as an Algebra 3-4 topic should just be the systems of quadratic equations without going through the lesson of how to solve a quadratic equation. But I think most of my students at this point could use a solid review on solving those quadratics in different forms. So we're going to go through quite a bit in this video. It's going to be a little bit long. If you only need to know certain parts of this, you might want to skip around. We're going to cover getting things into standard form. Then we're going to cover different ways of solving quadratics, so both by factoring and quadratic formula. Then we're going to cover different forms of the quadratic, meaning when there's not a b value or there's not a c value. And then we're going to get into the systems of quadratics. So with all that, depending on what you need to know and what you need practice with or help with, you may not want to watch this entire video. But if this is pretty unfamiliar to you, just the quadratic equations and all that, then I would watch the whole thing. So first off, when we solve these algebraically, we're going to be combining equations later on, and we need to have them in standard form. So I want to show you a couple different ways. So here we have the factored, or something's not working, factored / intercept form. And then over here we have vertex form. Now vertex form, if I have a y value, I can solve this for x by isolating. But because of the way that I'm going to use it today, I'm going to show you how to multiply that out and get it in standard form. So we're going to do that with both of these. First off, when I have factored or intercept form, I want to do something with this coefficient. So I want to go ahead and distribute that into the 2x plus 5. So 2x plus 10 is going to give me that new binomial, and then I'm going to multiply that by x minus 3. And I'm going to show you different methods for doing different parts, so keep that in mind. I'm going to distribute using the FOIL method, first, outside, inside, last. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. 10 times x is 10x, positive 10x. And 10 times negative 3 is negative 30. Then I need to combine my like terms. So 2x squared plus 4x minus 30. And then, of course, I want to have the y equals. So now I'm in standard form for that one. I'm also going to show you that box method, the area model. I'm going to go ahead and start with, now I'll go ahead and distribute that 2 in again. So I've got 2x plus 10 times x minus 3. So the area model, which many of you are familiar with from Algebra 1-2, you take your two binomials. So this right here, when I refer to a binomial, that's what I'm talking about. I have this binomial times this binomial. I'm going to take the two of those and put them on the outside. So 2x plus 10 and x minus 3. When we get to factoring, we're going to use this area model again in the opposite direction. So then I'm multiplying. The reason it's called an area model is because you're multiplying basically the length times the width. So x times 2x to get 2x squared. X times 10 to get 10x. Negative 3, don't forget the negatives, times 2x to get negative 6x. And finally, negative 3 times 10 to get negative 30. Then I want to combine my like terms, which are the 10x and the negative 6x, and write it out again in standard form. So y equals 2x squared plus 4x minus 30. So that's the two of the ways. There are a couple ways when you have a coefficient out front, but there's a couple ways to get that into standard form. Whichever one is more comfortable for you, then by all means use that. The next thing we're going to do, and this takes a few different steps here. When I have vertex form, I have x plus 4 squared. Really important thing to remember. X plus 4 squared is absolutely not x squared plus 4, or sorry, plus 16. The reason for that is this exponent is not, it doesn't have a numerical gift, such as like when we distribute something. This is telling us we're multiplying x plus 4 by itself twice. So what we have to do instead is take x plus 4 times x plus 4. When I do that, I can use either the area model or I can use the FOIL method. I'm going to go ahead and use the FOIL method. So I have x squared plus 4x plus 4x plus 16. So x squared plus 8x plus 16. So this trinomial, 3 terms, is the equivalent of this squared binomial. So now I need the rest of the equation in there. So I have y, not yellow, I don't want to do that in yellow, sorry. So I have y equals negative 3, and then instead of the x plus 4 squared, I'm going to have x squared plus 8x plus 16, and then I need that negative 5. Whoops. So I'm going to distribute first negative 3x squared. Negative 3 times 8x is negative 24x. Negative 3 times 16 is negative 48. And then minus 5, so I can combine those two things. This is all still y equals negative 3x squared minus 24x minus 53. So now I'm in standard form. So when you're going from vertex form to standard form, there's some important things to remember. One, order of operations. Do the exponents first, which means you have to multiply out that binomial. Then apply the a, then distribute the a into that trinomial, and then combine your like terms at the very end. A lot of places to mess up there. Most common is making mistakes with squaring, and then also negatives not coming down. So just be careful with that. Those are the two ways, or the two forms that we're dealing with: factored form, vertex form. Getting those into standard form, because we're going to want everything in standard form. Back. When I refer to a, b, and c, if I refer to a, I'm referring to the coefficient for x squared. If I refer to b, I'm referring to the coefficient for x. And if I refer to c, I'm referring to the constant. So just a heads up on that. I meant to say that earlier. All right, now to review how to actually solve those quadratics. Anytime you are solving a quadratic, you need to have it equal to 0, almost every time. So I'm going to make a note of that real quick when solving quadratics. Sorry. Get everything to one side. Whoops. To equal 0. The reason for that goes back to when we're solving quadratics, we're most often finding our x-intercepts. And so y equals 0 at those x-intercepts. That's the method we have for that. So this is with box and diamond, the area model, and it's just really a form of organizing things. I'm going to show you the same way with both, the same process. You don't have to do all of this, especially when you have the a value of 1. Real quick. Okay, so when I use the box and diamond, I start with my x squared in one corner, first term, and then my last term in the other corner, opposite corner. I'm going to take those two things and I'm going to multiply them. So this is going to give me 40x squared. Then I take my middle term, my b term, 13x, and put that at the bottom. What I'm looking for when I'm looking for my side numbers is what numbers multiply to get the top and add to get the bottom. And this is all just an organizational tool. So the first thing I'm going to do is I'm going to factor 40. I'm going to figure out what all my factors are of 40, and I'm going to do that in pairs. So whenever I factor a number, I start with 1 in the number, 2, so 40 divided by 2 is going to give me 20. 40 is not divisible by 3. 40 divided by 4 is 10. 40 divided by 5 is 8. 40 is also not divisible by 6 or 7. And then I'm back to 8, and I've already used 8 right here, so that's how I know that that I've listed all my factors. So now that I have all my pairs of factors like that, then I need to look at what that bottom number is. I want those factors to add up to give me 13. The pair that does that is 5 and 8. So I'm going to put 5x and 8x, and I'm going to put those in the empty boxes. Then I'm going to factor, my rows and columns. So from this column, I have 8x and x squared. There's no coefficient for x squared, so really the only thing I can take out of this is an x. And that's where, when I have the a value of 1, this part is pretty easy. X times x is the only thing that's going to give me, and I keep getting the wrong thing here. Oh my gosh. Sorry, x times x is the only thing that's going to give me x squared. X times 8 is going to give me 8x, and x times 5 is going to give me 5x. Last thing I want to double check is, does 5 times 8 give me 40? And yes, it does. So now I'm going to take x plus 5 and x plus 8. That is going to give me my factored form. X plus 5 times x plus 8. And that is my factored form. Now, if I want to solve this, if I have it all equal to 0, I'm going to use what's called the zero product property. We're going to do that in just a minute. Right now, I'm just going to focus on the factoring part. So that was factoring with an a value of 1. A different a value is going to be the same process, but you have to be a little bit more careful when you do the end factoring. So I'm still going to start with my first term, 3x squared. Last term is 8. I'm going to take those two and I'm going to multiply them. 3x squared times 8 is 24x squared. And I'm going to take that middle term with the negative, negative 14x, and put it on the bottom. So again, I need two numbers that multiply to give me 24 and add to give me negative 14. So when I factor that, I'm going to factor 24. I'm just going to do the all positives for now. I'm not going to worry about the negatives at the moment. I'm going to do 1 and 24. 24 divided by 2 is 12. 24 divided by 3 is 8. 24 divided by 4 is 6. 24 is not divisible by 5. And then I'm back to 6 and 4. Now, when I am looking at positives and negatives, if you have a positive number on top, that means your side numbers are either both negative or both positive. If your bottom number is negative, they both have to be negative because two negatives added together will give you a negative number and two negatives multiplied together will give you a positive. When you have a negative on top, then one of your two factors is going to be negative. You just have to figure out which one based on the bottom number. I'm not sure if we'll have an example of that before the end of the video or not, so hopefully I'll get that in there. Anyhow, if they add up to be negative, but they multiply to give me positive, then all of them, whoops, wrong function, all of them need to be negative. So I'm looking at what pair adds up to give me negative 14, a negative 2, and negative 12, and I'm so out of space on the side there, are my two side numbers. So negative 12x, negative 2x. Now here's where I have to be a little bit more careful. When I am factoring a row or a column, I have to look at my coefficient as well. This is not going to just be 2 and 12 over here because I don't have the same situation as I had over here. This was just x times x. Now I have a 3x. So if I look at this column right here, I have 3x squared and negative 2x. The only thing that can be divided out of those, the only greatest common factor from those is simply the x. So I can take an x out there. And here in this row, my two coefficients are 3 and negative 12. Both of those are divisible by 3. So I'm going to take out a 3x. So 3x times x gives me 3x squared. X times negative 2 will give me negative 2x. And then 3x times negative 4 is going to give me negative 12. The other way I can look at that is negative 12 divided by 3 would give me negative 4. So my factored form is going to be 3x minus 2 times x minus 4. And I didn't write the x plus 5 on the right line over here. All right, so that is a review of factoring using the box and diamond. Some people prefer a different grouping method. This is just mathematically, it's the same thing. If you have another method for factoring that works for you, then by all means use it. I'm doing the box and diamond because that's most familiar to students at this school. All right, moving on. Actually solving a quadratic. If an equation has an x squared but no x value, so what that means, like a full quadratic would have x squared plus, say, 3x plus 5. It has the a, b, and c. All three terms are there. This one doesn't have that, that b term. So in this case, the only x that I have in this equation is the x squared. So I can simply isolate x. So I can add 14. Then I have x squared equals 25. Now, when I undo a square, I square root. Here's the tricky thing. If you are solving for x squared, if you're using a square root to solve, you have to be careful about a plus or minus. And here's why. So let's say I take the square root of x squared, square root of 25. Most of us, when we look at that, would just go x equals 5. And there it is. Now, that's almost true. If I go back to this row right here, if I put in 5 squared, that's going to give me 25. But if I also do negative 5 squared, that's also going to give me a positive 25. So when you square root to solve, you need to add this nice little plus or minus. So, actually I'm going to take it off of that one. That kind of makes it confusing. So, when I have x equals, my two answers are going to be 5 and negative 5. And these little, I can't remember what those brackets are called. Anyway, that indicates, these brackets indicate that I have a list of numbers that could be my x value. 5 and negative 5 are my two answers here. You could also just write 5 and negative 5, if you wanted to write it like that. Anyway, when you're solving using a square root, you need to make sure you get that plus or minus in there. Another option is when there is no C value. And in that case, we can factor a greatest common factor out. Or you can treat this like it would be plus 0 for your C value and do everything the same way with either the box and diamond or with the quadratic formula, which I'm going to do in a minute. But there is a quicker way. If both of these have x's, then that means you can factor out a greatest common factor of an x. You can also look at the coefficients and recognize that 2 and 8 are both divisible by 2, so I can factor those out as well. What I'm going to do is show you basically what it is, the same area model, but now with only 2 boxes. So I've got 2x squared, negative 8x. If I'm looking at my row here, these are both divisible by 2 as well as x. So I'm going to take out a 2x. 2x times x is going to give me 2x squared, and then 2x times negative 4, or rather negative 8 divided by 2 is going to give me negative 4 to get that second factor. So if I rewrite this, this would be 0 equals 2x times x minus 4. And now I'm in factored form. I'm going to rewrite this again down here. So once I'm in factored form, I'm going to use what's called my zero product property, and I'm getting ahead of myself a little bit. But the zero product property tells us if I'm multiplying two things, in this case I'm multiplying 2x, whoops, wrong, nope, I don't want to be in that function, sorry. I'm multiplying 2x by x minus 4. And the zero product property says if you multiply two things together to get 0, then at least one of those things has to be 0. So we separate the two factors and set both of them equal to 0. So I have 2x, or just x for that matter, but 2x equals 0. Divide both sides by 2. And I have x equals 0. That's probably showing more steps than is necessary, but just the process is important. And then x minus 4 equals 0 as well. Add 4 to both sides. So x equals 4. So my solutions here are 0 and 4. So that's if there's no C value. But you can also go through the entire box and diamond and do that. You'd have 0 on top, or you can do with quadratic formula with C as a 0 instead. So I'm going to do the quadratic formula in just a minute. I'm going to show you a couple of different things first because this is all wrapped up in each other. So now I have something, I can't isolate x in this particular case. I have x squareds on both sides, x's on both sides, numbers on both sides, a constant on both sides. So because of the x and the x's, I need to get everything equaling 0. So when I have full quadratics, or when I have quadratics in general, most of the time, I need to get everything to one side. It's going to be easiest if I don't have a negative x squared, so I want to get that to the other side. So I want to add x squared. I'm going to also take away the 7x from both sides and the 15. So basically what I'm doing is I'm trying to wipe everything out on this side because I want it all equal to 0. So everything should be the opposite here. Positive 7, negative 7, 15, negative 15, negative x squared, positive x squared. All this is going to give me 0. So I've got 0 on that side. Over here I've got 2x squared plus x squared is 2x squared. 12x minus 7x or plus a negative 7x is going to be a positive 5x. And 3 plus a negative 15 or 3 minus 15 is going to give me negative 12. So that's the new quadratic that I'm dealing with. 2x squared plus 5x equals, minus 12 equals 0. So I can solve that by factoring. So I'm going to do that first. Then I'm also going to do it with quadratic formula to remind you how to do that. My colleagues and I kind of differ on this. They want to focus more on, some of them want to focus more on the factoring. But I think quadratic formula is a really important one to know how to do. Also because if you're looking for x-intercepts, you can always use quadratic formula. Not everything is going to be factorable as it is. So start with my first term, 2x squared. My last term, negative 12. I'm going to multiply those two to give me negative 24x squared. And then I'm going to take my middle term, that 5x, and put it on the bottom. As you'll recall from before, we got to factor that top number. We have 1, 24, 2 and 12, 3 and 8, 4 and 6, and then that's all my factors for 24. Now, the negative positive discussion we had earlier, if two numbers multiply together to give me a negative, then not at least, one of them has to be negative, and only one of them can be negative. So to multiply to a negative, one is going to be negative, one of them is going to be negative. If they have to add together to give me a positive, it's going to be the smaller number that's negative. If they added together to give me a negative, it would be the bigger number that would be negative. So I'm going to go ahead and make all my smaller numbers. That's the other benefit of factoring with that method, is you have your small numbers on one side and your bigger numbers on the other. And then I need to look at each of my pairs. Negative 1 plus 24 is 23. Negative 2 plus 12 is 10. Negative 3 plus 8 is 5. That is the pair that I want. Negative 3 plus 8. So negative 3x plus 8x. So I'm going to put those into my boxes. Now I'm going to look at any column or row. If I look at this row right here, I have 2 and I have negative 3. I cannot divide both of those by 2 and get a whole number. So I'm going to look at this column, 2 and 8. Those are both divisible by 2. And I also need to take out one of those x's. So I'm going to take a 2x out there. 2x times x is going to give me 2x squared. 8x divided by 4 is going to give me 2. The other way, sorry, let me say that again. 2x times 4 is going to give me 8x. If I can't figure that out off the top of my head, 8x divided by 2x is going to give me 4. That's what I was talking about earlier. So I got 4, and then x times negative 3 is going to give me negative 3x. Last thing I want to double check, negative 3 times 4 gives me negative 12, so I'm good to go. So now I have my factored form, 2x minus 3 times x plus 4 equals 0. And I'm going to use my zero product property at that point. Take each of these factors and set them both to 0. So 2x minus 3 equals 0, and x plus 4 equals 0. So then it's just a linear equation. Add 3 to both sides, so I've got 2x equals 3. Divide both sides by 2, and I have x equals 3 over 2, or I'm going to go ahead and put it as a decimal just for this one time. Then my other one, subtract 4 from both sides, I've got x equals negative 4. So x equals 1.5 and negative 4. Those are my two values for x. Next, I'm going to do the same one, but with the quadratic formula so that you guys are reminded how to use that. As I said before, I think most of the things that we're going to be working with for now are going to be factorable, so you can use factoring and zero product property if you want to. But if you come upon one that's not factorable, then use the quadratic formula. Eventually, you're going to have to use both for future purposes. Okay, so the quadratic that we got from up here, I'm going to go ahead and rewrite that. 2x squared plus 5x minus 12 equals 0. scoot this down, give myself a little bit more space. Now, quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c. And this is all divided by 2a. So here's what I have. I've got an a value of 2, I have a b value of 5, and a c value of negative 12. So I'm going to put all of those numbers in. So I have x equals, negative is from the formula, b is 5, plus or minus. By the way, that plus or minus has to do with what we talked about earlier with when you're finding an answer to x squared, you're going to have two answers. That's where that plus or minus comes from. B is 5. I'm always going to put this in parentheses because it matters when you're dealing with a negative b value. So I just get in the habit of putting it in parentheses. Minus 4 from the formula, a value of 2, and a c value of negative 12. Spread that a little bit further. All divided by 2 from the formula, and then the a value of 2. Now, there's varying degrees of thought as to how much work you need to show and how much you can put in the calculator. Generally speaking, what I recommend is that you take, sorry, trying to figure out how I want to do this, is that you take this part and plug it into the calculator exactly as it is. Don't do the square root sign. The reason I say that is because eventually we're going to be dealing with numbers that, with complex numbers, and I'll get to that later, but like later in the year, not later in the video. It's best to know what number is sitting under that square root sign. So when I put that in the calculator, I'm going to put it in with all the parentheses in place. Parentheses 5 squared, minus 4, parentheses 2, parentheses, parentheses, negative 12, parentheses. Then I'm going to push enter. So when I do that, hang on, I don't know what I get off the top of my head. Hold on. Okay, back to it. When I do that, I get 121. So I'm going to bring everything else over simplified. So I've got negative 5 plus or minus the square root of 121, all divided by 2 times 2, which is not 2, which is 4. When I take the square root of 121, I get 11. So negative 5 plus or minus 11, all divided by 4. Apparently I keep wanting to write 2 there. Once I am simplified, my square root is gone, everything's taken care of, I'm going to split this into a positive and a negative version. So I'm splitting this into my two answers. So negative 5 plus 11, all divided by 4. And you need to simplify the top before you divide by the bottom. Negative 5 plus 11 is 6 over 4, which is 3 over 2, reduces to 3 over 2, which is 1.5. Shouldn't be terribly surprising. And then I'm going to do negative 5 minus 11 divided by 4, which gives me negative 16 divided by 4, which gives me negative 4. So hopefully you have noticed I have negative 4 and negative 4 and 1.5 and 1.5. Badly circled. So those are the two different ways that we focus on. I mean, there are other ways, but two different ways of solving quadratic equations. Big step here that you may be completely unfamiliar with is when you have all this stuff on both sides, you need to get everything to one side equaling 0. Then whether you're more comfortable with factoring, do factoring in zero product property. If you're more comfortable with quadratic formula, then by all means use the quadratic formula. So that concludes our very long review of solving quadratics. Now we need to solve a system of equations, including a quadratic. So in this one's a pretty simple one, and this is as far as I'm going to go with it, because let's be real, this video is long enough. The first thing I'm going to do is figure out how to start with this. Right now I have a line and an equation. Now, what we did last section in 1.4, which I did not make a video for because it was basically 1.3 putting all together. If I have a line and a parabola, most of the time I'm going to have two graphs that cross probably in two places. So I need to figure out how to do that algebraically. Sorry, I keep losing my train of thought. Some of my methods of solving systems of equations had elimination, substitution, and some teachers refer to equal values method. I usually just call this substitution. If I know that negative x squared plus 8 is equal to y, and I know that y is equal to y, I know that this y is also equal to negative x squared plus 8. So a lot of teachers will refer to that as equal values method. These both equal y, so you set these two parts, with the negative, equal to each other. So either way, what I'm left with once I get that set up is negative x squared plus 8 equals negative 2x plus 5. So now I'm looking at a quadratic in which I have an x squared and I have an x, so isolating x is not an option. So I need to get everything on one side equaling 0. I don't want to have a negative x squared. It's a little tougher to deal with, so I'm going to add x squared to get rid of that. Be careful here, I'll talk about that in a second. And I'm also going to get rid of that 8 by subtracting it. So if I'm looking at the left side of the equation, everything over here is its opposite. Negative x squared, positive x squared gives me 0. 8 minus 8 gives me 0. So what I'm left with on this side is 0. Now, here's where you need to be careful. I added an x squared to the right side, but I don't have another x squared to combine it with. So I'm not going to combine it with anything. I'm just going to write it. Same thing with the negative 2x. There is no other value or no other term on this side that just has an x, so I'm just going to drop it down. Don't combine unlike terms just because they're sitting in the same place. And then I'm going to combine 5 and negative 8 to get negative 3. So I have many methods of dealing with that. So you can factor that if you want. I'm not going to factor that one. I'll go ahead and do quadratic formula to show you the instance where a equals 1. If you did factor this, this would factor relatively quickly to x minus 3 times x plus 1, if that equals 0. Then x minus 3 equals 0, x plus 1 equals 0, add 3, minus 1, and yes, I'm hurrying through this part because turned out I'm factoring without telling you, or without actually. Anyway, if you were to factor, that's what you would end up with, x equals 3 and x equals negative 1. Also going to show you quadratic formula. In this particular case, if I have 0 equals x squared minus 2x minus 3, I have 1 for my a value. Anytime there's not a number there, that's a 1. Negative 2 for my b value, and negative 3 for my c value. So x equals negative b plus or minus the square root of b squared minus 4ac, and I'm leaving space because I'm going to erase and plug in, all divided by 2a. So I'm going to take out my b values, and I'm going to put in negative 2. This right here is why I wanted to show you this. When your b value is negative in the quadratic formula, it can cause some confusion because we're going to end up with double negatives. Next thing I'm going to take out is my A, and I'm going to put 1s in there. Just for good measure, it's not, I meant to put the B's in red. So -2 and -2, not sure that's totally helpful. Anyway, and my C's, or just my 1C I should say, is -3. So when I simplify this, got x equals this double negative. This is why the parentheses and plugging things in are so important. Double -2 is going to give me a +2. Most common issue that comes up with quadratic formula is negatives. And then I end up with, if I do -2 squared, I get a +4. This is why I really recommend the parentheses over and over and over again. Because if you just plug in this whole thing exactly as I have it written with all the parentheses in place, then you'll be fine. If you forget the parentheses, oftentimes if you don't have parentheses around a negative number squared, it's got to give you a negative number. And that's the situation where you have to be smarter than your calculator. Any number squared is always going to come out positive. So this is going to give me a +4. And then -4 times 1 is -4 times 3 is +12. So I've got 4 plus 12, which is going to give me 16. Again, I can just do that in the calculator. I just need to be careful to put it all in parentheses. And then 2 times 1 is 2. Square root of 16 is 4. So I have 2 plus or minus 4, all divided by 2. Split that into the positive and the negative. 2 plus 4 divided by 2 is 6 divided by 2, which is 3. And then 2 minus 4 divided by 2. 2 minus 4 is -2 divided by 2 is -1. So, shouldn't be surprising. I have a -1 here and a -1 here, 3 here, 3 here. Now, those are the two separate ways of doing it. You don't need to do it both ways. Don't do it both ways. I'm just showing you both ways so that you know. But here's the thing. These are only our x values, and this is a system of equation. So x equals 3 and -1. Those are my two x values. When I'm solving a system, I am looking for a place on a graph where, and this is just whatever, a parabola and a line are meeting. I'm looking for those two spots. That requires that I have a y value for both of those as well. So I'm going to take either equation. I can use my first one or I can use my second one. The linear is the easier one to use, and you can use it both times when you're solving for your y's. I also want to show you the -x² plus 8 though, because it's such a common problem because of all the negatives. So first thing I'm going to do, I'll do it in the linear. This is a simple way to do it. My first x is 3, so I'm going to take the second equation, y equals -2, and I'm going to plug in, sorry, not -3, just 3. So I'm going to plug in that 3, and then plus 5. So this equation is just from up here, and I'm plugging in one of my x values. So y equals -6 plus 5, so y equals -1. So one of my answers is the point 3, -1. So that's one of my answers. The other one, I'm going to use the same equation. There's no need to switch equations when I'm solving for my other one. Is an x value of -1. So I'm going to plug in -1, and then plus 5. Y equals -1 times -2 is a +2, plus 5, so y equals 7. So my other point of intersection is -1, 7. That's my other answer. I could be done. I'm done. But I do want to show you, if I chose to do that, find y with this equation, I want to show you what that would look like because it's such a common mistake. Whoops, nope, not what I wanted to do. There we go. So I've got negative x squared plus 8. So y equals negative x squared plus 8. Let's say I want to take my negative 1, that x value, and I want to use this equation to maybe check my answer or to solve it, either way. I'm going to take out that x, and I'm going to put in that negative 1. When I evaluate this, the first thing I have to do is squared. This negative is part of the original equation, so I have to leave it there. But this negative 1 squared is going to give me a positive 1. So I'm dropping down, didn't want to be in that color, dropping down everything in black, negative. But I'm taking this and doing that math, and that's going to give me a positive 1. So now I just have 1 plus 8. So this is where the confusion tends to happen. The negative came down. This math was turned into negative 1 squared became 1, because negative 1 times negative 1 is 1. Negative was already there, and it needs to stay there. So now I have negative 1 plus 8, which gives me 7. So I just wanted to show you that, because that negative out in front of an x squared can cause a lot of confusion, and I didn't want it to be like the demise. But if you have a linear equation on your system, whoops, if you have a linear equation on your system, that's going to be the easiest one to use to find your y values. All right, so that concludes this extremely long video on solving systems of quadratics. If you have, just a couple of things, if you have two equations here, remember you need to get them in standard form. If you have a factored form one, you got to multiply it out and get it in standard form. If you have a vertex form one, you have to multiply it out and get it standard form. Once they're in standard form, that's when you're going to set them equal to each other, solve for x using either of these methods, factoring or quadratic formula. And then once you have your x's, then you have to solve for y. So this is a many step process. And we covered a lot in this video. I hope it helps. So have a lovely day, and thanks for hanging in there. Bye-bye.